The next shipment of supplies for the International Space Station is due to leave Earth next week from a launch pad in Japan. The Japan Aerospace Exploration Agency's fifth H-2 transfer vehicle begins a 4-day flight to the station from the Tanegashima Space Center now on Monday morning. Today, we'll get the latest on the preparations and the mission from NASA Flight Director Royce Renfrew, the HTV-5 lead flight director. So let's first talk about the timing. I think, originally it was scheduled and planned to take off on Sunday. So what happened?
So the one thing we don't get to control is weather. We always have to keep track of the weather, just like all rockets that are going to launch. There are weather constraints. The weather in Tanegashima was not looking good for a Sunday launch, so they decided to delay it a day, and we'll get off the pad on Monday and get there on Friday. So, I can't control the weather, nobody can, but that'll be fine. We'll just delay it one day and it'll be fine.
This particular mission, HTV-5, is what's new about it?
So there are a couple new things for this vehicle in particular. The end cone of the HTV-5 is available this time for stowage going uphill and coming to bring trash home as well. So that gives us a little bit more volume to bring food and supplies and scientific research equipment up to the ISS. You mentioned about 4.7 tons of hardware. That's good. We're also bringing up some common water carriers for water coming uphill. We have about 30 bags of water. Various equipment that also, after the recent incidents that we've had with some of our vehicles, we got some critical spares on board HTV-5 as late load hardware, some equipment for our regen Eclipse system, and some other equipment for EVA folks in particular that we're bringing uphill. So new, we'll be able to put hardware in that end cone, and we've also changed the rendezvous trajectory just a little bit for this mission. We used to have a period of time in the first 4 missions where there was a position behind ISS where HTV would go do a little football out there to make sure everything was ready to go on board ISS before they came in. None of the other visiting vehicles do that activity, so for this mission we got rid of that, what's called an AI hold, approach interface hold. We got rid of that, shaved about 2 hours off the rendezvous timeline. It gets us in line with the other visiting vehicles that are out there. So a couple different things, but predominantly it's HTV mission, pretty much the same as we've always had.
Just new and improved.
Just new and improved, that's right.
Okay, so you did talk about a bigger volume, so which is good because we have big stuff going up there.
Yeah.
So talk to me about the galley that's going up.
Yeah, so we are flying up 2 complete racks for ISS. One of them is the galley rack, which will go into the Node 1 module.
Okay, this is the U.S. segment.
In the U.S. segment. Oftentimes the ISS is described as a 4-bedroom house or a 5-bedroom house, and that's very true, but the one thing that the ISS doesn't have is a kitchen. It has the ability for the crew to get water out of a potable water dispenser in the lab. There are suitcase-sized food warmers that are scattered around. There are a couple of what are called Merlins, which are refrigerators where they can keep their food cold when they want it cold, but it's not all consolidated in one space. So we're going to get a kitchen, a galley rack that's going to go in the Node 1 module. We'll move the potable water dispenser there. It comes up with its own little refrigerators called Merlins, and it has its own food warmers there. So it has water, it has a refrigerator, and it has a stove, if you want to think of it that way. And that'll all be in one place in Node 1. I'm sure the crew will appreciate having that. The other big rack that we're bringing up goes into the GEM module, the Japanese module. It's called the multi-purpose small payload rack, or MSPR. It's a plug-and-play piece of equipment. ISS is a good place to do that. You fly any science that you want, and you can plug it into the MSPR, do the research, and then take it out and put another payload in there. This will be the second MSPR. We already have one on the vehicle, so we'll put that rack in the GEM and move forward from there.
Very good. So big stuff, and then also some big science. And I know that there's the electromagnetic levitator facility.
Yeah, ELF.
Correct, ELF. And then also Calais. What can you tell me about Calais?
So briefly? Calais is so first of all, ELF is one of the experiments that'll go in the MSPR, so that's inside the station.
Okay.
Calais is designed to do research into dark matter, and it goes outside the station Outside the GEM, the Japanese module, there is what's called the exposed facility. It's a little area of station where we can insert payloads and take them back out. So Calais will be installed in one of the ports on the exposed facility after it arrives on HTV-5, and it'll start doing scientific research into dark matter.
And what about replacing any of lost items that were lost on the previous cargo crafts?
Yeah, there's a piece of hardware called a multi-filtration bed, or MF bed. You may hear the conversation. It's part of our regenerative ecosystem that takes all the water that's produced on station, cleans it up, and then makes it back into drinkable water. The regen system also cleans up all the atmosphere, has a carbon dioxide removal assembly, various equipment to keep the environment inside ISS habitable. One of the pieces of equipment that we need for that is this multi-filtration bed, which we're flying up. Also, there are some components for U.S. spacesuits. We're not flying up an entire spacesuit on this vehicle, or EMU, but we're flying up some components and some filters. Chill in the airlock today doing a loop scrub. Whenever you do a loop scrub, you have to have various filters to flow the water through, bringing up some of those components on the vehicle as well.
Thank you so much.
You're very
Royce
welcome.
Renfrew, the lead flight director of HTV-5.